start. So let's just start, and then again I'll share afterwards, or I'll rather share after we've done tomorrow the whole thing. But I'll definitely share the link by this evening already. Okay, so basically we ended last week still on confidence interval. So I just want us to, this was I think one or two more of a confidence interval that I just want us to make sure that we get it right. So again, the things that we need to look out for. I just want to see how big the font is. So that is perfect. Okay, so simple random sample of size 46 from a normal distribution results in a sample mean with the sample standard deviation of 15. Okay, so definitely not Z. We're working with a T because it's sample standard deviation. So the population standard deviation is unknown. Okay, so then let's just see. When it's normally, we will need to go to the T table. So let's do the degrees of freedom first. Alpha divided by 2. And that multiplies by standard deviation divided by n. Okay, so they tell us the sample mean is 300. Then they tell us, okay, so we first need to work out what that t value is. So simple random sample of 46. So we know that for the degrees of freedom, that is 46 minus 1. And then we need to see 90% confidence interval. So if we're working with alpha divided by 2, that alpha is equal to 1 minus 90%, which is equal to 10%. So we're actually looking for t that is 45, and then 10% divided by 2, which will then be 5%, which would give us 0.05. So we will need to find that t value on the table. So let me just get, so we say T45, 0.05. Okay, then we get it 1,679. 1,679. So just again, why we're using T, because we don't know the population standard deviation. We only know the sample standard deviation. So that is why we use the T. So 1,679. Standard deviation still 50 divided by your n, which is 46. So calculator work here, 50 divided by square root of 46. So it's 1,679. I get times 7.3721. At this stage, I still keep it at 4 decimals. I could have probably started rounding it off because I will end with 2 decimals, but let's see what happens. So I get 300 plus minus 12,38. The easiest one for me first is to do the top one and see when if I get an answer. And it is, so option C is the correct one. Problem if you used the Z, then your answer would have been, let me quickly check. Luckily, your answer would not have been here. Let's quickly check what we would have used for 90%. So for 90%, we would have set 1.645. 1.645 times 7.3. So luckily, your answer would not have been here. So that is at least good. But I think the most important, it is a T that we're working with. When we do the T, we need to remember to go to, we need to get the degrees of freedom, and we need to see what alpha is. So that is the most important thing in this one, was how to get that value. Okay, then the rest is standard how we calculate it. Okay, the next one also a confidence interval, but this time the confidence interval is a bit different. So let's read through it and let's just get the right formula, get the right things that we need to have here. So consider the following application exercise from a previous assignment. Okay, we don't have it. Most of the schools reported a decline in number of absences following the education department. In a sample of 150 students, from Joe Harvey's district municipality, 114 schools reported a decline. And then 90% confidence interval. Okay, so what are we working with in this instance? So is it somewhere? So okay, so where have I said it? Okay, so we're working with a proportion. So we're working with this formula of the proportion. Remember, proportion is always Z. So we're working with Z at least, but with a proportion, we have a bit of a different different formula that we use. Okay, so here we would have needed to calculate the p-value, which is 114 divided by 150. So 114 divided by 150 is equal to 0.76. Okay, so I just look at 0.76. It's in the middle. It's in the middle. Okay, so obviously here they made duplication errors. Again, it happens in the exam. It will be corrected. So if one of those two is the correct answer, it won't matter which one you will select, but it's not supposed to happen. But if it does, it will be to your benefit, not to. So all they will drop the question, or they will take, if B is the right answer, they will take B and C. If D is the right answer, they'll take D and E. Okay, but let's see what we get. So 0.76 plus minus. We're working with 90% confidence interval, so Z is 1.645. And we still need to work out what that is. So it's 0.76 and 1 minus 0.76 is equal to 0.24. Still divide by 150 because that is n. Okay, so 0.24 times 0.76 divided by 150. Take the square root of that. So we're basically sitting with 1.645 times 0.0349. I'm hoping you guys are also getting that, and 0.76 still in front. So for me, always the easiest is first to do the plus. So it's plus 0.0574. Okay, now this instance, they do 3 decimals, so it's very difficult nearly to beforehand know where you're going. But if you add those to 0.817, which is option A. So that's why I normally keep with 4 decimals, just because then at a later stage I can round up, instead of starting with 2 and then, because if that was 2 decimals, it could have been 0.82, and then you start worrying if the next one is 0.83. So for me, it's just I start off with 4 decimals, and then I will reduce it according to what the answer is in the end. Okay, so that covers the confidence interval. So there's a proportion that you can get. There's one that's a t that you can get, and then there's one that that gives you, interesting. This looks nearly like the same set of data, but one that is a population standard deviation. So just important that you're able to identify which one you use for Z, which one you use for T, and then when there is a proportion involved as well. Okay, so that is confidence intervals. Okay, questions thus far, or can we just continue with the next one? Okay, so let's continue with the next one. So now we're starting hypothesis testing. So there's a few things that we in hypothesis testing that I think it is important. So let's quickly go through this. In a sample of 36, okay, so we have a sample mean of 83. It is also known that the population standard deviation is 16. You are required to use this information to test the following hypothesis. The null hypothesis is small or equal to 80. The alternative is bigger than 80. Okay, which of the following statements about the test is incorrect? Let's just see what do they give us. The t-stat is that. At something we need to do that. At something we need to do that. Upper tail Z test is applicable. Sure. Okay. There's a lot of weird information in this one. Okay, so let's first look at if we needed to calculate the Z, how would we have done it? Okay, so that would have been our formula for Z. So it is 83 It looks more like this. Okay, so we have a sample mean as 83. We're going to test it against 80. We have standard deviation as 16 and n as 36. Okay, so 80 minus 83 is going to be minus 3. So I'm feeling this one is going to be incorrect. 16 divided by square root of 36 is 6. So minus 3 divided by 2,667. That's very small print. So that answer is minus 1,125. Okay, so the t-stat that we calculated is minus 1,25. So that is definitely the wrong one.
John?
Yes, I just want to check again. Yes.
Sorry. Is it 83 minus 80 or 80 minus 83? Because the sample mean was 83, right?
Okay, so
See?
so what's the sample mean? So if you look at those two values, which one is the sample mean and which one is your x?
X is the sample, right?
Let's just look at this again. Hmm. Okay, so when you look at that, so just to get to that, I just want to look for that formula so that we just make
Okay, cool.
the right call here. So okay, so they're telling us that the sample mean is 83. They're asking us if 80 differs from your sample mean. Okay, so here they could have said, so what would you have done if it was 81? Would you then have said that is 81? I just want to get your thought on that one.
If they said sample mean was 81, then I would not have used, I wouldn't, what you have there is not right. I would have used the X is 81, because the sample mean is 81, not the U, because that's
Okay,
population, right? Yeah.
okay. See, so, and I think the catch here is
Yeah.
we so it's nearly we want the bigger one to write that first. So what we are testing here is we're testing your sample mean, and I think let's go nearly back to page 1 nearly. So let's just, you might have a point. Let's go back to what is it? Chapter 1. Okay, so that is a statistic for sample which you are now have identified. And here they say, I should have just looked at, you're right. I should have just looked at the signs or thank you very much for that, Lynn. So the bottom part was still correct.
Yeah.
It There they tell you. So I was so fixated in that, but there they tell you what your mean is that you're working with. And that is 80. So you are 100% correct. It is this way around. And I should have just gone back to first principle. So first principle is sample mean study unit 1 that we did way back in March, April. It's the same as that. Okay.
Okay,
So
cool.
they tell us the sample mean is 83. So you are absolutely spot on. Okay, so and then I think that is important because I don't know if there is one that I've included. No, so there is a definition question on this that I will try to find where they do put the two in different spaces. So let me remember to add that for you guys as another example. So you're spot on.
Okay, and
Sample mean, sorry?
sorry, John, just quickly, if the null hypothesis didn't have the equals to, less than or equal to, and if it only had less than, if that's possible, would we still use 80 in that case, right?
Yes,
Okay.
yes. So it, yeah, so it should always be something with equal.
Equal
So
to.
equal, less than or more than with the equal. But if not, still use the 80, because it's again the continuous distribution. So if it was with discrete and those things, discrete, binomial and Poisson, then it makes a huge difference. But when it is with your continuous, so your normal distributions and also your chi-square that we are going to do after hypothesis testing, that is all continuous. So that they don't really need to, but the correct way is to say smaller or equal to. But they don't. It's not always the necessity to do that. Okay, so then it is divided by 16 divided by 36. 3 divided by, so we're just writing this below down, which still gives me 1,125, but sorry, positive. That's weird. That they say it's still the wrong one by fluke. um, I just want to make it. Did anyone else work it out? Because
Yeah,
since they
1.125 sounds right. Hey,
just
it's wrong. Yeah.
just because they're using it elsewhere as well. Okay, so that is then definitely wrong. So let's quickly just check then. Okay, so that is, so let's say 1.125 is there, and we need to, so that will be your p-value that we're looking for. So 1 minus this area will give you that. So let's go to 1,125. Okay, so now we should round that off to 1,13. Or what they can say is, is that you need to get the value between. So it can be that I say look for a value between 1.12 and 1.13 because that is in the middle. So let's just look at those two options and see if there is anything nice in the middle. Else you round it up. So 1.12, 1.10, 1.11, 1.12, 1.13. So you can now see 8686. Let me just write it down. So 1 minus 0.8686 gives us 0. I don't like this question. This 1 minus the 0.8708 gives us 1 or 0.1292. So what is the value in the middle? Add the two together and divide it by 2. It's a long process again. So in between those is 0.1303, which is then correct. So that p-value, they wanted us to get the value in between the two. Don't really like that because I would have probably wanted to round it up and work with that. Okay, so that's. But let's quickly look at the other things as well. So at a 10% level of significance, the rule is to reject the null hypothesis if a test statistic is greater than or equals to 1,285. See now, I just want to see where that table was that we used with the percentages. It here, then at least. Okay, so at 90%, we do work with a 1,285, so that is correct. But now, what I don't like, so now they say 1,285 because it's linked to that, which is that, but it should have been 1,285. So again, now I just don't like this question because there's so many things that in here is now misrepresented nearly. So at a 10% level of significance, the null hypothesis is not rejected, which is also because that number is smaller than that number. Also, your p-value of 0,1303 is bigger than 0,1. So there's two reasons why we why the null hypothesis is not rejected. The one is, let's write it down here. The one is that your critical value that you calculated is smaller than your, sorry, so your critical value that you calculated 1,125 let me do it for a third time. Your T stat that you calculated is smaller than your critical value. It is very confusing now even for me because that and that is exactly the same. And that's what they wanted to achieve with this question. And the second reason is your p-value that you calculated bigger than your 0.1 level of significance. Okay, so you can always, so there's two ways that you can identify it is if your p-value that you calculated is bigger than the level of significance, null hypothesis is not rejected. Also, when the t-stat that you've calculated is smaller than your critical value, the null hypothesis is also not rejected. So it might be, I haven't seen it in a question yet, that they only give you options around p-value and level of significance, and they don't even show any of a t-stat or a critical value or anything like that. So that you nearly need to know that there is another way to identify if you will reject or not reject the null hypothesis. And then an upper tail Z test is applicable. That is an upper test. If it was negative, and that should have been also identification. If it's negative, it will be a lower tail. So what they can also say is a right tail or a left tail. So it's they can, so there's three things that they could have used. So they could have used upper is one, they could have used right, or they could have used positive. Okay, so just, and if it was referring to the other side, it would have been lower tail, would have been left tail, or it could have been your negative tail. So just those three that can be. They sometimes in your confidence intervals, and I don't think I showed any here, so I will check if I can find one. They might just ask you to work out one of the two. So the question can be something like, work out the lower confidence level or the upper confidence level, so that you only need to work out one. So then there will only be one answer, but it might be that they give both to you. I have seen it before, so I'll just go through my notes to see if I can find one of those questions as well. Okay, so hypothesis testing, um, I think that, and we'll do a few more on other things that you can have in hypothesis testing. Um, but I think the important thing with hypothesis testing is that you the null hypothesis, and as we've seen here, the null hypothesis will always include some kind of equal, then the opposite needs to happen with alternative. So if it's equal to, the alternative needs to be not equal to. If it's smaller or equal to, it needs to be bigger. If it is bigger or equal to the alternative. So just, it might be that they do this in a question where they give you A, B, C, D, and E, and they tell you the one null hypothesis is equal to alternative is this. Then there's another one where we do this. Okay, so that you know that if those were the two options, then that will be the right option to pick. So just look for, and I'll check previous. There will definitely in all the previous papers that I shared today on the group. There definitely will be something like that in there. Okay, so let's quickly look at this question. Suppose the calculated t statistic for a one-sided lower tail. Okay, so now we get some of those other words. Okay, one-sided lower tail is minus 2,74. Okay, we don't know yet what they're asking us. Suppose further that the population standard deviation is known. Okay, so that just tells us that it's Z, that is 0, so we can assume that we're working with a normal distribution. What is the p-value for the test? Suppose the calculated t-stat for one-sided lower tail test is that. Okay, so they want that value. Okay, so there might be a catch in this one. So let's just check. So let's go to minus 2,74, and it will probably highlight it. So you can see I have used it before, 0,0031. Okay. If it, and there we have the answer, which is correct. If it said two-sided, if it said, suppose the calculated t-stat for a two-sided test is still minus 2,74, suppose further that, then what will your p-value be?
Multiply by 2.
Perfect.
Yeah.
Okay, perfect. So, because if it is then two-sided, here will also be the same. So you would have multiplied it by 2, and there was actually an option for that. So again, it might be in your exams that in the one question set they asked it for the one-sided, and in the second question set they asked it for the two-sided. If that was plus 2.74, it would still be for one-sided upper tail test, it will still be that. And for if it was two-sided and it was plus, it will still be 0,0031 times 2. Okay, so I think it's very important nearly to see all these other ways that they can ask it, and you nearly get to the same answer sets. And that is nearly how it will be in your two. I think there's 3 or 4 different exam papers that options that will be available. And which ones you write, it's it's all random. So it, and I think that is also just for you guys to know, it is not that there's just 4 different papers. It is question 4 is random, or question 1 is random, question 2 is random. So, and we've done permutations and those things. So there is not just 4 examples of a paper. There can be 12 questions with 4 different or 5 different or 4 different versions. So just remember that. Okay, so this one was a weird one because we don't really see this in, and nowhere was here even hypothesis testing mentioned. But one of the things of hypothesis testing is to look at p-values, because that is where you're gonna say yes or no, you're gonna accept or not accept. Okay, so the next one. So again, very interesting. So here we talk again about hypothesis tests, but again, they want something else. So consider a two-sided hypothesis test with 5% level of significance, 25 degrees of freedom. So they already tell you that your degrees of freedom is 25. So we are going to work with a T. And then the alpha, they give us as 5%, so 0,05 divided by 2, which is, what is it, 0,025. Okay, so they already give us, remember that the degrees of freedom is 25. Okay, so degrees of freedom 25, 0,025. So let's go to the T. 25, 0,025, so we sit with 0,060. Sorry, 2,06. Okay, so option A. Let's just check. So if we went with 24, it would have been 0,64. I don't think there was an answer 0,64. So there at least wasn't. If we went with 0,05, 1,708, 1,708. So if we went with 0,05, you probably would have picked it or chosen that one. So just important again that we need to divide by 2. And then that is the correct answer. If you went Z with a 95%, which is 1,96, you would have gotten that one. So again, now we're going, and this is again weird to have it at hypothesis testing. That's why I included it in here. But this population standard deviation is unknown is way back in study unit 6 and 7, and then it is used in study unit 9 again. So I think just important to nearly see how they use some of the other study unit information and work into the rest of the question sets as well. So yeah, I think this is just important that and that's why I included it, that it not always just a straightforward hypothesis testing exercise. Okay, we've still got a few minutes, so let's carry on. This one is on chi-square. For me, this is the important thing that you need to know on chi-square. So there will always be these, what is it? It's nearly 5 things that they will talk about in chi-square testing. So that is when I look at chi-square, and that is chapter 10. I nearly, I don't know if I copied it in all of them, but I will. I look at this nearly every time first, and then check what is in the question, so that you don't need to nearly remember all the things, because this is a basic that you need to remember from chi-square. So let's look at the question set. Which of the following statements is incorrect about chi-square test of independence between 2 variables? The t-stat has r minus 1, c minus 1 degrees of freedom, r minus 1, c minus 1, where r is the number of rows and c is the number of columns. Okay, so that is A that we are looking at there, correct. Okay, we're looking for the incorrect one. The observed frequency of each cell is equal to rho times total divided by n. Rho times total divided by m. But they say observed. What we are calculating is actually the expected. So it's not the observed, it's the expected. So option B is wrong. The two variables is qualitative. That is always the case with chi-squares, always two qualitative variables. The null hypothesis is that two variables are independent. Null hypothesis, two variables independent. And this is always like that. So null hypothesis always looks at the independence. The alternative or hypothesis one always look at non-independence. So they might use words like not independent. Another word is dependent. So again, so if they don't use not independent, they can also use non-independent or they can use dependent. So if it's not dependent, or the opposite of independent is dependent. So that is another one that they might use in a question set. So just another thing I think it's important to note is the terminology that they might use. Okay, and then the last one, the observed and the expected frequency for each cell are equal, then the t-stat will be equal to 0. Okay, so if the frequency of observed and the frequency of the expected is equal, that is what they are saying, that will be 0. 0 to the power of 2 stays 0. So that is also correct. It's actually not defined, but let's not go into that detail. Your answer will be equal to 0. Okay, so and that is by having this table with you. So again, easy for me if one has this table, because it, again, pressure of the exam, you look at that, you're like, "Yuck, but that makes sense," and you totally forget that they actually they saying observed, and that formula is for expected. So again, just nearly the focus of that. So that's why this table really does assist. Okay, let's go for the last one. In a table, 9 rows, 2 columns, what's the degrees of freedom? So 9 minus 1, 2 minus 1, so that is 8. That is 1. Your final answer is 8. And it seems weird that this feels a very easy question compared to all of the others. And you're nearly looking at this and you're asking, but why is it so easy? And I think that is the importance nearly of doing the mock exam and see how quick, because this can be maybe the second last question of your exam, and you maybe have 3 or 4 minutes and you're like, okay, but what do I do then? And there might be easier questions, but it is unfortunate again that you can't go back to a previous question. So yeah, but when you nearly start running out of time, see if, like what we've done, we can talk about this tomorrow as well. But see nearly if there is things that that you will be able to nearly eliminate out of the answer set. Okay, so tomorrow we will just do another one of the chi-square, and then we have I think three on correlations and things like that, and then um, yeah, we can also just add one or two other questions, and then we will have a session again next week before you write, just to make sure everything everything is nearly settled for you guys. So definitely tomorrow we will have a session, and then next week, probably on the 25th, I think I'll have a later session in the evening around 6 o'clock, for you just to we just check in, and if there's questions you can ask that before you write on the 27th. At this stage, so I'm still recording so that if somebody else is listening, but I will repeat it tomorrow as well. At this stage, they still looking at making, so your exam time is at the moment, I think, between 9 and 11. They're trying to see if they cannot open that up, that you can write any time nearly between, I think, 9 and 4, um, so that load shedding schedules can't hamper you in the exam. So we will hopefully get that notification by Monday. So at the moment, it's still the set time, but the lecturer is looking into and trying to get that it's open for a longer period of time for you guys. So let's just hope for that. But as soon as I get feedback, I will let you know. It is open exam, so please, it is open exam, so don't worry about that. You're not using what is that tool you're not using Iris, so don't worry about Iris anymore. You're not using it. You're using the what is on Moodle. Um, there has been things that have, and if you have gone through some of the questions, and I have seen on the group that there was questions around, but I can't see this row and or extra thing because the camera is situated in a place. It was brought under the lecturer's attention, so that you will you will go through the whole exam on Moodle and check if there's anything that might be hidden in a question, and then you will rectify it before you write exams. And I think that is why it's so important to do the mock exam nearly, to see if there's anything weird that you're picking up, so that we can let the lecturer know that he still has time to rectify things. It's the first time it's on Moodle, so it's the first time. So just if you go through the mock exam and pick up anything, let me know. So it was nice that there was a chat on somebody that had one of the rows was missing. Um, so the lecturer already knows about that. So it won't be changed on the mock exam because that don't count for anything. But if you had a question like that in the exam, you will already start rectifying that and make sure that it doesn't happen in the exam as well. Okay, that that is it then for this afternoon. We'll check in tomorrow. We'll finish then the prep tomorrow for this, but we will still have conversation. and I'm still bombarding you with things that I pick up. So you will just get more things um, on on our group, and it is basically just extra stuff for you to work through and to study. I'll also, if you want, Lizzie's um, when we'll share the information when she has her last or second last sessions as well. And you can join her sessions as well. So we will just make sure that in this last week, all the e-tutors are nearly working together so that we can just see that you get the most prep time in and the most exposure to anything that might be in the exam. Okay, guys, have a good evening, and then we'll see tomorrow morning again. I'll send the updated um, calendar now for 9 to 10 tomorrow morning. But at least one can sleep in a bit later. Okay, cheers, and have a good evening, everyone.
Cheers,
Thank
John.
you.
Thanks.
Cheers.
Cheers, all.
Bye.
Yeah. All right.